Like honestly, out of all of chapter 2, I think this is probably my favorite section. Maybe even like if you do like chapters 1, 2, and 3, even 4, because I hate chapter 4. We'll get to that later. I love talking about ratios, rates, and conversions. So the second half of chapter 2, what I love about the second half of chapter 2 is, I know you guys sit at home every day after I teach you all of this super fun math stuff, and you're like, man, I love math so much, and it's so fun, but how can I use this in real life? You ask yourself all the time. It's not like, how are we ever going to use this in real life? It's like, how can I use this in real life? Because it's so cool. I want you to put this to use, right? You ask yourself that all the time, right? Yeah, you guys awake? You here? Okay. The second half of chapter 2 is the best real-life application. So today we're going to talk about ratios, rates, and conversions, okay? So let's start here with a couple of definitions. So a ratio compares two numbers by division. A ratio compares two numbers by division. Honestly, a ratio, for the most part, is going to look like a fraction. It doesn't have to look like a fraction, but most often, a ratio is going to look like A over B. Now, the difference is, if it's a ratio, there's a couple different ways you can say it. You can say A over B, but you can say A to B, because you're comparing A to B. That's how you would say that. Sometimes they write it using a colon, and then sometimes you could actually write out the word to. This book primarily uses a fraction. Okay, so just know that written as a fraction to be a ratio. It's comparing the numerator to the denominator. Now, if we talk specifically about a ratio that compares quantities measured in different units, that's what we call a rate. For example, two quantities in different units might be like 60 miles per 1 hour. 60 miles per 1 hour. Okay? Or $5 for 6 apples. Comparing two quantities, right? 60 and 1, but they're in different units. Miles, hour, dollars, apples. Okay? Now, whenever we talk specifically about rates, what's going to be a little more helpful than just like a normal rate, like 60 over 1 or 5 over 6, is what we call a unit rate. Okay? A unit rate is a rate that has a denominator of 1. So instead of saying it's $5 for 6 apples, the unit rate would say, here's how much it costs for 1 apple. Okay? It's easier to compare different deals and things like that if it's a unit rate, because you know the price for that one item, or how fast you're going for 1 hour. Okay? And then lastly, one of the big things we're doing today, which you may have done in science, either last year or this year, if you want to convert quantities or rates to different units, we use what's called a conversion factor. A conversion factor. Now, a conversion factor, it's a ratio that has two equivalent measures in different units. But here's the big thing. It's always equal to 1. Here's what I mean by that. An example of a conversion factor might be 12 inches to 1 foot. Okay, this is a ratio of two equivalent measures, but in different units, right? Inches and feet, but 12 inches and 1 foot. Isn't that the same thing? So this is equivalent to 1, because 1 feet is 12 inches. So it would be 12 inches over 12 inches, which is 1. Okay? Big thing, it has to be equal to 1. Okay? Now let's talk about some of the things we're going to be doing today. One thing is we're going to work on writing rates as a unit rate. So the purpose of doing this, maybe I have something like, okay, we have a sale that has a bag of 6 apples for $3.99. Great, but if I really want to know if that's a good deal, I might want to know, okay, well, what's the cost for one apple? Because maybe I know what a good price is for one apple. I don't really know what a good price is for 6 apples, but I maybe know in my head, what am I willing to pay for one apple, and I can kind of go from there. So what you first need to do is you need to write this as a rate, okay? Typically, if you're talking about cost, you're going to write it as cost per item. So in this case, we're going to say $3.99 for 6 apples. Now, if it's a rate, it's very important that you include the units, okay? We don't just want to say 3.99 over 6. I want to be specific. $3.99 over 6 apples. Now, if this is a unit rate, I need that denominator to be 1 apple. So what I need to do is I need to go from 6 to 1. Well, how do you go from 6 to 1? And I will say, you can't use addition or subtraction. We could divide by 6. Now here's the thing. I can't just divide the numerator by 6. Sorry, I can't just divide the denominator by 6. I also have to divide the numerator by 6. So if you take 3.99 divided by 6, that's going to give you about 67 cents for 1 apple. So now you know, probably a pretty decent price for them. Okay. So that's one of the things we're going to do today. Okay, the other thing, and this is something that maybe you've done in science before. Okay? This is my favorite thing to do. I love doing this. Okay? We are going to write, okay, so the big thing here, sorry, this is converting things. Okay? So the first thing we're going to do is we're going to convert your teacher's age to seconds. My age to seconds. Okay? So to do this, this is the big, most important thing here, guys. We're going to use a conversion factor to do this. What you are trying to do here is you are trying to cancel out units. Just like whenever we cancel out fractions, okay? So I know we haven't really talked about multiplying fractions, but if I'm multiplying a fraction and I have something like this, 2/3 times 3 over 4, we could just go ahead and multiply across. But one thing that makes multiplying fractions easier is if you cross-reduce. Does that sound familiar? So you could cancel out those 3's. The only reason you can cancel out those 3's is because one's in the numerator and one's in the denominator. If they're both in the numerator, they could not cancel out. The same thing happens with units. So if I have an inches in the numerator, it can cancel out with an inches in the denominator. That's the biggest thing you guys have to remember today. Okay? So let's try this one. Okay? So if we want to convert your teacher's age to seconds, we need to know how old I am. Any guesses? Maybe I should ask that. What? 7. Yeah, thank you for that. I am 30 years old. 30 years. Okay. So we want to convert 30 years into seconds. Now I will say, sometimes when you do this, there's going to be a direct conversion where you can just say, oh, well, years to seconds, there's this many seconds in a year. Yeah, I don't really know that. I don't know about you guys, but I don't know how many seconds are in a year. So we might need to take a couple of steps, okay? So between years and seconds, there's a couple of units there. What's from years? What maybe should I go to before?
Days.
Probably days. Okay, so here's what I'm going to do, guys. I need to cancel out years. I don't want years. So if I want to cancel out the years is in the numerator. So to cancel out the years, I need to put a years in the denominator. Those are going to cancel out. And I want to convert from years, and we said to days. So what I like to do is I like to do the units first, okay? Now remember, this is a conversion factor. This has to be equal to 1. These have to be equivalent measures. So then I need to say, okay, well, how many days are in how many years? What's the equivalent measure there? 365 days in a year, right? Okay, so look what happens here, okay? The years cancel out. If I were to multiply these together, this would tell me how old I am in days, which is great, but I don't want to know how old I am in days. I want to know how old I am in seconds. Okay, well, I don't know how many seconds are in a day, so maybe I need to go from days to what? Okay.
Hours.
Probably hours. Now, remember, guys, I want to cancel out days. If the days is in the numerator, to cancel it out, I need to put the days in the denominator. And we said we wanted to go from days to hours. Well, how many hours and how many days? There are 24 hours in one day. And look, the days cancel out. This would tell me how old I am in hours, which is great, but I don't want to know how old I am in hours. I want to know how old I am in seconds. Do you know how many seconds are in an hour? Maybe you know that one, or maybe you need to do one more step. What do you think? Probably to minutes. So once again, the hours is up here, so I need to cancel it out and put the hours in the denominator, minutes in the numerator. How many minutes and how many hours? 60 minutes and 1 hour. Notice the hours. See how one's in the numerator, one's in the denominator. And then finally, I can cancel out the minutes and convert minutes to seconds. And there are 60 seconds in 1 minute. Guys, and look, see how the minutes cancel out? See how every single one of these units canceled out? And the only unit I'm left with is seconds, which is what I want to know. Now to figure out the number, I've got to multiply all this together. Now luckily, this one's pretty easy, because see how the denominators are all ones? So these are the easy ones, because you don't have to worry about dividing. So all you would have to do here is multiply 30 times 365 times 24 times 60 times 60. And oh my goodness, guys, that gives you 946,080,000 seconds. It's a lot of seconds. And I guess we're just adding to that as we go. That would have been in February, but it's pretty old. You're supposed to say, no, Miss B, that's not old. Okay. Okay, let's try one that has 2 units, okay, because these are the ones that are a little bit trickier. So if we want to convert 500 meters per second to miles per hour. Now, the last one was just 30 years. It wasn't a rate. A rate, remember, has 2 quantities. That just had 1. This is a rate because we're talking about 500 meters per second. So what you need to do is you need to write this as a rate. So we're going to say 500 meters per second. Now they don't give me a number with the seconds, so it's going to be a 1. So 500 meters per 1 second. Now what I want to do here is I want to convert this into miles per hour. So what I need to do is I need to change meters into miles, and then I need to change seconds into hours. So let's start with miles, okay? I want to change meters into miles. So the big thing you need to understand here is I don't want the meters. I need to get rid of the meters. So if the meters is in the numerator, in my conversion factor, where will the meters need to go? Down here on the bottom. So meters to miles. Okay, probably don't know this one. And that's fine. There's going to be some conversions today that you don't know. In your textbook, I will give you the page number because I don't know it off the top of my head. In your textbook, there is a table that gives you every conversion factor you could possibly need to know today. I will give you that whenever you guys get started on your homework. Okay? In that conversion table, it's going to tell you that in 1 mile is equal to 1,609 meters. That's what it's going to tell you in your book. Okay? This is why I like doing the labels first, okay? Because I can see, okay, I've got miles over meters. Then what you're going to do is you're just going to take these numbers, the 1 mile, put the 1 with the miles, and then the 1,609 meters, put that with the meters, okay? Now notice the meters are gone. I have miles. That's what I wanted to do, okay? I've got the miles. Great. Now I need to go from seconds to hours. Now do we know seconds to hours? There's like a pit stop in there. Probably seconds to minutes and then minutes to hours. Now be careful here. Where is the seconds starting at? It's on the bottom. So to cancel out the seconds, where do seconds need to go? Up here, right? Look, that's the only way those are going to cancel out. Okay? And we said we wanted to go from seconds to minutes. And we know there's 60 seconds in a minute. So 60 seconds in 1 minute. Okay, see how the seconds cancel out? So if I were to multiply this, notice the units I haven't crossed out yet are miles per minute. Great, but I want miles per hour. So this minute, see how it's on the bottom? If I want to cancel it out, I need to put minutes in the numerator. And then I can go from minutes to hours, and there are 60 minutes in 1 hour. And notice those minutes are going to cancel out. And just double check before you multiply. The only units left are miles per hour. Miles per hour, which is exactly what I wanted. Now notice I do have a unit in my denominator. So how you're going to multiply these out? The easiest thing to do is multiply all the numerators, multiply all the denominators, and then divide them. Okay? So if I were to multiply all the numerators, the only denominator other than 1 is 1,609. If you divide those out, you're going to get 1,118 miles per hour, which is very fast. And this is kind of an easy section to just kind of double check and make sure this makes sense. If I were going 500 meters, and we may not be super familiar with meters, about a foot, okay? If I'm going 500 meters in a second, that's pretty fast, right? So 1,118 miles per hour, yeah, that'd probably be pretty fast, okay? Questions on any of that? Yes?
I have a correction. So for the, isn't it supposed to be for the unit, what are you, MI/ish?
Yeah, probably. All right, let's get this glued into the next open page in our notebook. Should be page 19. We're just going to keep adding on to our table of contents here. So page 19. Okay, page 19. And this is 2.6 ratios, rates, and conversions. All right, so one of the things you're going to do today is talking about unit rates. The best application of unit rates is to compare prices. And guys, I'm telling you, this is something you can use in real life if you're at the grocery store or, really anywhere, buying anything that comes in multiples or bulk. And you want to know, well, this one has 20 items. This one has 30. So obviously the thing with 30 items is more expensive. But really, which is the better buy? The better buy is going to be the one that's cheapest per item. And it's hard to compare things. If you've got 20 items here and 30 items here, what you need to know is, okay, what is the price for one of those items? And then you can make a decision on there which one you want to buy. So the first one is we want to know which would be the better buy. I could buy 6 bagels for $3.29 or 8 bagels for $4.15. Obviously 8 bagels is going to cost more, but I'm not going to know which is the better buy until I know, well, in each one of these scenarios, how much does one bagel cost in that scenario? So the first thing I need to do is I need to write each of these as a rate. Now, for rates, if it's cost, you're going to write it as cost per item. So for the first one, and sometimes it's not given to you that way, it's 6 bagels for $3.29. So I'm going to say $3.29 for 6 bagels. The other rate is 8 bagels for $4.15. So it's $4.15 for 8 bagels. So what I want to do is I want to figure out, well, in this first scenario, what's the cost for just one bagel in this scenario? Okay, what's the cost if I were to break it up into one bagel? Well, how would I do that? What do I do?
Put 6.
You guys, you're just going to divide by the denominator. That's all it is. So we're going to divide the numerator and the denominator by 6. When you take $3.29 divided by 6, you get about 55 cents for one bagel. In that first scenario, it's about 55 cents for one bagel. Now, if I were to buy 8 bagels, this time we're going to divide by what? By 8 this time, yeah, you just divide by the denominator. So $4.15 divided by 8 would give you 52 cents for one bagel. So just barely, which is the better buy? The 8 bagels, just barely. So that 8 bagels is going to be the better buy. If you don't want 8 bagels, probably not going to, cost you your retirement if you pay 55 cents for a bagel. Okay? All right, now let's talk about the conversions. And this is the part that tends to be the tricky part of what we do today. So number 2, let's say we want to convert 63 yards into feet. I want to convert 63 yards into feet. Now here's the thing, guys. On some of these, you may be able to just say, okay, well I know that there's 3 feet in a yard, so I'm going to do this and this. That's fine. But guys, I want you to do your work with the crossing like the way that I'm showing you. Okay? Because here's the thing. There's going to be some of them that you're not going to be able to do that to. So I want to see you working across, crossing out the units, multiplying, and doing those kind of things. Okay? So what we're going to do is we're going to first write down the unit that I'm given. I'm given 63 yards. Okay? I want to convert yards into feet. If you know a direct conversion, great, we're just going to use that. But before I do that, I need to multiply by a conversion factor. Okay? The first thing I would do, I want to get rid of the yards. Okay? Yards are in the numerator. So to get rid of it, I need to put yards in the denominator. Well, do I know yards to feet? Is there a direct conversion there? Yeah. So I can just go ahead and say, okay, yards to feet. Well, how many feet are in how many yards? There are 3 feet in 1 yard. And you can see that the yards cancel out. The only unit left is feet, which is what I was wanting. Now these ones are kind of nice because the only thing in the denominator is a 1, so you don't have to worry about the denominator. So you would just take 63 times 3, which would give you 189 yards. 189 yards. Okay, let's say we have 2.5 pounds. Yes. Oh, you are very right. It is feet. Thank you, thank you. 189 feet. Thank you. Okay, so for number 3, let's do 2.5 pounds into ounces. 2.5 pounds into ounces. Okay, so you're going to start by writing down the unit you're given. I've been given 2.5 pounds. And I want to convert pounds into ounces. So I know that I need to get rid of the pounds. So in my conversion factor, where does the pounds need to go? On the bottom, right? Now, you may not know this one. Once again, there's a table in your book. I'll give you the page whenever you guys get started on your homework. But there is a direct conversion from pounds to ounces, so we can just go ahead and fill those units in. Does anybody know what it is? There are 16 ounces in a pound. So there are 16 ounces, so that's going to go next to the ounces, in 1 pound. Notice the pounds cancel out. Great! My denominator is just a 1, so I can go ahead and just multiply across. So 2.5 times 16 will give me 40 ounces. Any questions on the first 2 there? Okay. What if I want to do 9 yards to meters? 9 yards into meters. Okay, so we'll start by writing down our 9 yards. Okay, now, when you're looking in the back of the book, what you're trying to look for, the first thing you're looking for, okay, is it going to give me a direct conversion from yards to meters? Unfortunately, it doesn't, okay? But it will, okay, so if it doesn't give you, you don't see something that says this many yards equals this many meters, you need to look, it maybe gives you meters to something close to yards. And what it does is in the back of your book, it will tell you that there are 0.305 meters in 1 foot is what it's going to tell you, okay? So it gives you meters to feet. It does not give you meters to yards. So what I need to do first is I need to change yards into feet, and then I can use this conversion factor down here. So I need to get rid of the yards. So we're going to put yards in the denominator. And we said we're first going to go from yards to feet. So how many feet and how many yards? And that's just above. 3 feet and 1 yard. Okay, see the yards cancel out. Great. Now I can use this down here. Okay, but guys, before you start filling in the numbers, do the units first. I'm trying to get rid of feet, so they need to be on the opposite side of the fraction. And I want to go from feet into meters. And then we're going to use our conversion here. So there are 0.305 meters. So the 0.305 goes next to the meters in 1 foot. Once again, these ones are nice when they all when there is no denominator, okay, because you can just take 9 times 3 times 0.305, and you should get about 8.2 meters. Okay, let's do one more of these. Okay, number 5 would be 89 centimeters. We want to convert that into feet. 89 centimeters into feet. So once again, what you're going to do is you're going to look at the back of your book and you're going to hope and pray that it gives you centimeters to feet. And it doesn't. But it does give you centimeters to inches. So what you have to look for is you kind of have to think ahead. You have to say, okay, well, I go from centimeters to inches and then inches to feet. So you're going to have to kind of connect the dots there. So what it tells you is that in 1 inch, there are 2.54 centimeters. That's what it tells you. So we're going to start by saying, okay, I have 89 centimeters. To get rid of the centimeters, I need to put centimeters on the bottom. And I'm going to go from centimeters to inches. And we know that in 1 inch, there are 2.54 centimeters. And then I want to get rid of the inches, and I'm going to go from inches to feet. The inches cancel out. There are 12 inches in 1 foot. 12 inches in 1 foot. Now, what you would do on this one, and I didn't write this stuff out in my notes, and I can't do that math in my head, but you would take 89 times 1 times 1, which is 89, okay? But then you're going to take 2.54 times 12, and you would take 89 divided by that, which is going to give you, I believe it's about 2.9 Okay, questions on that one? Okay. So these two are pretty much the same thing, except maybe we have a couple of units that we're mixing together. So copy and complete each statement. Let's say I have 7 feet 3 inches, and I want to convert that all to inches. 7 foot 3 inches, I'm going to convert all to inches. So I have some inches, right? I have those 3 inches. What I need to do is I need to take that 7 feet, and I need to convert it into inches. Do I know a conversion from feet straight to inches? Yeah, right? So we're going to go feet to inches, and there are 12 inches in 1 foot. Okay, the feet are going to cancel out. Now, 7 times 12 gives me 84 inches. Is 84 inches my answer? No, because it was 7 feet and 3 inches. So if the 7 feet is 84 inches, how much is 7 feet and 3 inches? 87 inches, right? Okay. Last one here. Okay, this one is a good one. I like this one. Okay. So the average monthly salary in Calcutta, India. Where we heard that before. We did a lot of work in, I know it's spelled different, but we did a lot of work in Calcutta, India. And what's her name? Yeah, Mother Teresa. Any? See, Teresa of Calcutta in here? Nobody? Okay. So in Calcutta, India, where Mother Teresa did a lot of her work, the average monthly salary, how much they take home a month, is 26,000, what they call rupees. That is their currency. Okay. I want to know what would this be as a yearly salary in American dollars. I mean, it's 26,000 rupees. I mean, man, if that was dollars, that would be amazing, right? But let's see what this looks like. Okay. So what we want to do is we want to take 26,000 rupees per month. That's their monthly salary. So we want to take 26,000, and the short for this is IR, Indian rupees, per 1 month. For 1 month, okay? I want to convert this into a yearly salary of American dollars. So I want this dollars per year, okay? So first one, the one we're kind of more familiar with, let's go from months to years, okay? If the months is in the bottom, in my conversion factor, where's the months going to need to go? On the top. So months is going to have to go up here, and then years will have to go on the denominator. And there are 12 months in a year. See how the months cancel out? Now what I need to do is I need to go from Indian rupees to dollars, and they give you the conversion factor here. $1 is 71 rupees. So, in my conversion factor, where's the rupees going to go? Great. See how it's in the numerator? So it needs to go in the denominator over here, and then the dollars is going to go up here. Now the conversion, they say in 1 US dollar, there are 71 rupees. Okay, here's what this is. I want you to keep in mind, this is in Calcutta, India. You do 26,000 times 12. Divide that by 71. You are going to get $4,394 per year. You guys know what a good salary is here in the United States? I would say like teachers and firefighters, that's what me and my husband are. I mean, starting out making anywhere from $40,000 a year, which is about, honestly, like if you have a combined income, okay, about that much a month. What probably, I would say the average family here in the United States takes home in 1 month, that's what they make in a year. Isn't that amazing? In a bad way? Very, very poor nation there, which is why Mother Teresa was so called to do her work there, because the poor, the working poor, I mean, that's crazy. So, anyway, I don't know if you guys are in St. Teresa to Calcutta, but something to think about today.